Hi and hello dear friends, welcome back once again to our channel VAAGAI Academy of Mathematics, and this playlist is where you can find video lessons for CAT, MAT and other management exams. This session we have an interesting question from the concept of time, speed and distance. The two here our question is based on the concept of train problems. So such an interesting question we have with us. So let's see what question here we have. Trains A and B are traveling in opposite directions. So there are two trains, train A and train B. They both are traveling opposite direction. Okay, we should properly note it. So they are traveling in opposite directions. Can cross a stationary man. So they both are going to cross a stationary man. Stationary man in the sense a man who is going to stand at a place. He is going to remain in one place. Okay, he is not moving anywhere. He is going to stay in the same place where he is. Okay, a stationary man in 32 and 45 seconds respectively. That is, they are given the time taken by the two trains to cross that stationary man. So the first train is taking, train A is taking 32 seconds to cross the man, and train B is taking 45 seconds to cross the man. This is what is given here. And also they both cross each other in 40 seconds. That is, those two trains which are traveling in opposite directions, they both take 40 seconds to cross each other. Okay, so they both to cross themselves, okay, to cross each other, to be very clear, to cross each other they are going to take how much seconds? They are going to take 40 seconds. Okay, so this is what is given here in this question. Then what we have to find here is find the ratio of the speed of train A to that of train B. So we are asked to find the ratio of the speeds. Okay, so train A speed and train B speed. So this ratio is what we are finally asked to find, and we have the options. Okay, so the question seems to be much interesting, and also it seems to be it is missing with so many data. Okay, though we are able to understand the question, so it seems like we are missing with so many data which are required. Okay, so anyways we need to solve and then get the answer. So that is the reason I said this is an interesting question. Okay, so what we will plan here is we will try to solve this question first in a conventional way, in a detailed way. Okay, so first we'll try with a conventional way, and we will try using a very brilliant shortcut. Okay, a really brilliant shortcut. We'll use it to solve the same problem using the shortcut. Okay, yes, so we're going to handle both the approaches. So let me start with the conventional approach first, and before that, so when we look at the question, so clearly if you see here, there are three different cases mentioned here, given here in this question. One is there are two trains are here. Train A crossing a man, we have got a time. Train B to cross a man, we are given the time. And train A and B to cross each other, they both travel in opposite direction, that we have to remember. Okay, they both travel in opposite direction to cross each other. Train A and B, they both cross each other. It is taking another time taken. Okay, so this way we have given three information. So with this we are asked to find the answer to the question. That is, we are supposed to find the ratio of their speeds. This is what we have. So we'll clearly note down the data here. So we have got three things here, right? So that is train A to cross the man. Okay, to cross the man. Okay, to cross the man. So let me write like this. So for this is what we are given 32 seconds. This is 32 seconds. And next is train B to cross the man, so for which it is taking 45 seconds. So that also I am noting down here. And last one more thing is train A and B cross each other. Okay, so I am writing A and B, okay, cross each other. Okay, A and B to cross each other, it is taking how much? 40 seconds. It's taking 40 seconds. Okay, so let me write it clearly. Okay, 45 seconds. This is 45 seconds. So 32, 45 and 40 seconds. So this is what everything is given in terms of seconds only. And finally we have to find the ratio, right? Okay, of the speeds. And as I told, we have some informations which are not provided in the question, but no issues. So now we will try to solve in a conventional way. So that means what we will try to do here is we'll assume some basic things. Okay, all right. So that is, first thing is we have train A crossing a man. That is, this train A is going to cross a man. So what happens when a full length train is going to cross one stationary man? So what happens? The train has to travel how much distance? The train should travel its own length. Is it or not? So that means we have to define something here for the length of the train A. And same way here, if you come to the second case, here we have train B crossing a man. So again here, in order to just mention this or explain this, we need train B's length also, and here A and B. So we need both their lengths. Okay, of course we need the lengths of train A and train B, and in turn what happens is, since they are going to cross a man, those trains are going to be the only moving objects. That is, train A crossing a man, train A is the only moving object. Train B is going to cross a man, train B is the only object, moving object. So in that case, we need their speeds also. So we need to assume their speeds also. So that is, we need to assume the lengths of the two trains A and B, as well as the speeds of the two trains A and B. So all these things we have to we just have to assume it, and then only we can just start solving this problem. So let me do a very clear thing. So I'm just going to write A and B here, okay, just for an assumption, okay, A and B here. So what I'm going to do is, I'm going to take the lengths of train A to be like L1 and length of train B to be L2. Let me take this way. And next is, we just need the speeds also, right? So what I'm going to do is, I'm going to assume the speeds also. I'm going to take speed of train A to be like S1 and speed of train B to be S2. So I think all the things that we require, that we need to solve this problem, are available now in terms of some assumptions. All right, okay. So these are going to be the variables we'll be using here to solve this problem. Okay, all right. Now we'll come back to each of those cases. Okay, first case we have train A is going to cross a man in 32 seconds. So that means train A to cross the stationary man, that means the train should travel its own length to cross that man. Is it or not? So in that case, the train A should travel how much distance? It should travel a length of its own length, a distance of its own length. That's it. Okay. So in that case, it should travel L1. Okay. All right. So L1, I'm writing L1, and for which it is taking how much time? It is taking 32 seconds. So that is, here we got the distance. So what's the relation between distance and this time? It's simple, right? Distance by speed we'll be getting the time. So that means what we can do here is, simple thing, what we can do, L1 divided by, what about the speed here? Because train A is going to cross the man, is it or not? So in that case, we have to take speed of train A only here to be the speed. Okay. So that means here we'll have divided by S1. This is what is equal to 32. Okay, all right. I'm just going to equate it like this. All right. So we get L1 by S1 is equal to 32. Okay. And one more thing is, these are all default things. Like, what are all the default things? I'm going to take this length to be in terms of like we'll have a standard units to be meters. That'll be better. And speed, we'll take it to be like a meter per second. Why I'm especially taking like this is, like, this we have in meters and this we have, if we have in meter per second, the time what we will be getting will be by default it will go with seconds itself. It will be in terms of seconds itself, because in question itself we are given in terms of seconds only. See the time taken, they are all given in terms of seconds only. So better we'll have them to be like a distance to be the length to be meters and the speeds to be in meter per second. Okay, anyways, that is not going to affect the problem, but anyways, to standardize, I'm just writing it. Okay, all right, yeah, fine, continue. Now come to the second case. What do we have in the second case? Second case, we have train B crossing the same man. It is taking how much time? It is taking 45 seconds. Let's try to build another relation here. Okay, so train B is going to cross the man, so that means now we have to take the distance traveled by train B, which is going to be the length of the train B only. All right, okay, so that means L2 divided by, now which train is crossing? Train B itself is going to cross. Okay, in that case we have to take train B speed only, so that means by S2. This is what is equal to like 45. Okay, I'm going to equate this to 45. Okay, this is also over. And last, one more relation also we need here. So what is that relation? Train A and B, they both are going to cross each other. So this is what we have. So now imagine when two trains are going to cross each other. Now what happens is, now both the trains are moving as well as they are going to move in the opposite direction. So this point is really important for us to solve this one. Okay, to just take this relation. Okay, what we have to do here, when two trains are going to cross each other, basically what will be the total distance? The distance will be nothing but the sum of the lengths of the two trains. Okay, so that means we'll have L1 plus L2 divided by, what about the speed here? Speed here will be nothing but we have to add their speeds. Why? Because they are both traveling in opposite direction, right? So when they travel in opposite direction, what would become for the relative speed? What is the relative speed of the two trains? I mean, like relative speed of the relative speed of one train with respect to the other. We just need to take the difference. Okay, so, right? So if we take the, we have to take the sum. Okay, I'm sorry. So we have to take the sum. In that case, we'll have to take the addition. Okay, we have to take the addition, sum of the two speeds. Okay, so we just have to add S1 plus S2. So in that case, L1 plus L2 divided by S1 plus S2 will be equal to this 40 seconds, right? Okay, so two trains are going to cross each other and the distance will be the total, I mean the total length, I mean the sum of the totals divided by the speeds is going to be the speed is going to be the relative speed which we have to add it. Okay, so this will be equal to L1 plus L2 divided by S1 plus S2 is what is equal to 40. Okay, so from the three cases given in the question, we have formed a clear relation. Okay, we have formed like three relations we are able to form here, but actually what we need here to find, so we need to find what? We have to find the ratio of the speeds of the two trains. So that is, we have to find the ratio of the speeds. Okay, so we actually need the value of this S1 is to S2. This is what is asked in the question. Okay, all right. So this is going to be quite simple because we have formed the relation here, right? So what next we can do here is like we can just try to write everything in terms of S1 and S2 itself. Okay, so once we try to do that, it's going to be very easy. So look at here. So what we can do here is like we have L1 by S1 is equal to 32, right? So what I'm going to do is I'm just going to write this L1 as 32 S1. Okay, we can very well do that, right? Same way here L2 will be equal to 45 S2. So why I'm doing these things is like I can now take this L1 value and L2's value, I can just substitute it here in this third relation. So what happens here is, so let me just separate it. So what happens here is like, let me just replace this L1 by this 32 S1 plus this L2, I can write it as 45 S2 now divided by S1 plus S2 is equal to 40. I can just write this way. And what next I can do here is like I can just take this S1 plus S2 to the other side so that this will become 40 times of S1 plus S2. Is it or not? So what happens next is like we'll have 32 S1 plus 45 S2 will be equal to, let me just take this S1 plus S2 to the other side. It will be just multiplied with that 40. So what happens is, let me just bring that 40 also inside. So what happens is like we'll get 40 S1 plus 40 S2. Is it or not? So this is the way we'll be getting. And next what we can do is, as usual, we will just try to bring like terms to one side. Okay, that is S1 terms we'll try to take one side and S2 term the other side. So if we try to do it, what we'll have is like we'll be having it like 45 S2 and this is 40 S2 plus 40 S2. So let me bring this one here. So we'll get 5 S2 because like we'll have 45 minus 40 which will be 5 S2 which is equal to this side, right hand side we'll have 40 S1 minus 32 S1, so that will become 8 S1. So as usual what we'll have is like we can easily develop now. So what we can have is like we'll have S1 divided by S2 is equal to, from this itself we can just get the division, right? S1 by S2 is equal to, we'll like get it to be like 5 by 8. Is it or not? So that when you cross multiply we'll be getting the previous step itself. So we can even check it. So we'll have 8 S1 is equal to 5 S2. We can check it here, right? Okay, so like this 8 goes here and this 5 will be staying here, this S2 will come here. So we'll have S1 by S2 is equal to 5 by 8, and obviously we got S1 by S2 is equal to 5 by 8. So that means S1 is to S2 is going to be 5 is to 8, and that's going to be the answer for this question. Okay, so yes, so interestingly we got the answer. So we tried to replace everything and we just got everything in terms of speeds of the two trains, and that helped us to get the ratio of the speeds of the two trains. And this is going to be the solution of this problem through a conventional way. Let's try working the same problem using an easy shortcut method, that is by the method of alligation. So let's see how easy this problem is going to be. Okay, yes, so we have just got three cases here, right? Very simple. So train A to cross a man, it takes 32 seconds. So train A is taking a time of 32 seconds to cross a stationary man. Okay, I'm writing train A, and under that I'm just writing 32 seconds, the time taken by train A. And here let me write B. This denotes train B. Okay, so train B to cross the same stationary man, it is just taking 45 seconds. Okay, so let me write 45 here. And now what I can do here is, trains A and B, when they just run in opposite directions, they are taking, what time they are taking? They are taking 40 seconds to cross each other. Is it or not? So that 40 seconds, let me just try putting in between, little below. Okay, so now I am going to use alligation. So just put this alligation marks, and always whenever we try to use alligation, we have to always start from the greatest number. So here this 45 is the greatest number. So 45 minus the mean value 40. So what is 45 minus 40? This is going to be 5 is to this difference. Okay, now just take this 40 minus this least value. Okay, so 40 minus 32. What about this difference? This difference is going to be 8, and that's it. That tells the answer for this question. So the two trains A and B are traveling in a speed of ratio 5:8, and that's going to be the answer for this question. Okay, so like, hope you enjoyed this easy shortcut method. And however, the answer what we got here, 5:8, is available at option D. Option D, 5:8, is going to be the answer for this question. Okay, yes, I feel that you are able to understand both these methods, and also you find it to be you found it interesting. So yes, if you feel that this session was useful for you, this problem, the way of solving it is useful for you, please do like this video and also subscribe our channel to follow other videos. And also, if you feel that this would help any of your friends who are preparing for any such competitive exams, please do share this video to them also. And yes, again, we'll catch up in the next session as early as possible. See you soon there. Thank you so much.